Not used to the Michael Jackson style of mics. Okay, welcome everybody to my talk about Zotonic. My name is Arjan Scherpenisse. I'm from the Netherlands, and I'm a self-employed software engineer doing all kinds of stuff, and amongst others web development with Erlang using the Zotonic web framework. So today I'm going to be talking to you about Zotonic and in relation to its performance. Yeah, well, let's build a website. So how do people build websites? Well, they go into the web, they Google, I want to make a website, so they install something like LAMP or WAMP or what have you to some kind of the most simple stack you can find on the web. So hey, there we go. I have PHP installed. Let's just build a website. It's good. Everybody uses it. There's a lot of stuff out there. Well, let's build a website. Okay, so I deploy it. I put it online somewhere. I have a visitor. Well, that's nice. Visitors, right? Everybody loves visitors. Until, of course, you have too many visitors. And then you think, oh no, my blog got too popular. So it's all gone. My website hangs. I have no clue why. And then you might think, well, maybe I got too popular. Maybe there was something I got mentioned on Hacker News or maybe on Slashdot or Reddit or whatever because I did something cool. And then my PHP got too many processes. Apache got too many processes. Things started timing out and everything got locked up. So nobody could reach the site anymore. Well, it was a simple blog site, right? It was just my blog telling about this cool stuff I'm making. So there's a global meltdown. But PHP is so simple. Well, you can use PHP, of course. And you can also solve the scaling problem in some kind of way. You can throw more hardware at it, like upgrade your VPS or your hosting provider to sell you some bigger machines. Well, maybe you can hire a sysadmin or make some kind of caching proxy, put some kind of extra hardware there, or memcached, or some infrastructure to get everything running more smoothly when you're starting to become popular. Use a bit of that. There's a lot you can do, but you're basically just adding complexity all the time. Every time you do something to your site that just started out as a simple blog, it gets more complex because you need to be able to handle more people. And of course, you don't want any downtime. You want to keep it running all the time while you're developing your stuff and writing about it. So the problem is not that you really cannot scale. The problem is that most people don't think about, when they make a website, they don't think about scaling at all, or they just take the technology that's out there and they think, well, it's easy, so let's just use it. But it would be nice if that same software could just scale out for you immediately. So yeah, that's what I was saying. So there's a process per request, and there were too many processes on your system, or maybe you didn't have enough open ports, or who knows what. So you got slashdotted. But what those slashdot visitors were doing, they were visiting your page, and they were looking at the same content. And they were all doing the same thing. So, I mean, a computer is good at repeating stuff, but should it really? And then you can observe something. And most websites that we visit, I think like 99% of them are just websites, really pretty simple websites. They have information on them. They basically are less than a million pages big, right? They have databases and stuff like that, but they never get so complicated, well, unless you have a few huge ones. But then you need to write special software anyway. So I'm not talking about the Facebooks, about the Twitters. I'm talking about the rest of the websites out there. And actually what's also true is that most of those pages are never visited by anybody except for the Google bot. And you won't get that much traffic. There's usually on a website, when something is popular, you have a blog post, everybody views that blog post. Maybe they click around a bit, they view something more, but the stuff that you wrote 3 years ago, probably they won't find it, or they won't bother going for it. So there's a relatively small set of hot data that you want to keep close. So that's why we're making Zotonic. So we want to in some way hit the ground running with a lot of this stuff. We don't want you to, when you're building websites, we don't want you to have to worry about all those. Basically, there are traps waiting for you that you know that you can encounter. So Zotonic's goals are, well, first of all, well, it's always hard selling Zotonic because it's Erlang. And probably I don't need to sell it to you because you're not web developers probably, but it's there's like this we want to make it friendly for people to use. You know, we don't want to say, yeah, this is this programming language by Ericsson and it's functional. What's functional? You know, so we want it to be targeted towards front-end developers so they can get started really easy without having to do a rebar compile basically. So the front-ender is in the driver's seat. And that also means that he's in control of what gets displayed on the pages. Then the second goal is that we want to have a reliable performance. We're not saying we're the absolute fastest web framework out there, but we're also not saying we're the slowest. We want to have a good performance that scales up to like this, some upper limit. That's probably dictated by your hardware. Yeah, so this web server, it should be able to handle the load, the usual traffic of what most websites in the world are doing. And at the same time, well, we're maximizing the use of hardware. So we're trying to do stuff, we're trying not to duplicate ourselves. Do more with less hardware. And we also want to be self-contained. So that's where Erlang comes in, right? You have just one release, one package, you install it. And there's no configuration overhead, or less than with your regular LAMP stack. And while we're developing it, we want to be able to keep Zotonic, your website, running all the time without going down, without having to restart. Like when you change something in a template, you don't want your website to go down and then go up again. It's just, it should be simple, and it should be simple to develop, and because websites are never finished, right? You always need something more. There's always a client on the phone asking for this extra features. So, well, that's what the Zotonic goals are, and then people ask, yeah, what is it all? So there's a lot of features in the box, and actually, we think at the moment there's a bit too much in the box. But actually, it's we're working on that. I'll come back to that. So going quick over this, Zotonic has support for multiple websites, so it has virtual hosting basically built in. So you make a website, and they're on your same Zotonic node are running multiple websites at the same time, all having their own set of, you know, template, files, layout stuff. There's an admin interface where you can do basic content management tasks, like managing users, pages, menus, moderating comments. Well, there's some image resizing stuff that's really interesting, so you can always have your images at the right size without having to do much work. There's of course all the content in Zotonic can be translated. And we support well, sending of emails and also receiving of emails, which is pretty interesting for CMS. We have some modules to import stuff, like we have a WordPress importer module, and someone's working on a Drupal importer module right now. There's a REST API for just doing standard JSON kind of stuff. Well, there's a lot, and there's also this external module repository that contains even more. Yeah, this is all in the box. There's, I think, even more that I forgot to name it. Actually, we have in the current Summer of Code, there's a student from Africa, and he's going to work on modularizing this some more and making the basic of Zotonic more lean, so that you can just install the modules that you actually need without like getting this big box of things that you're afraid of to use because it's so much stuff. But we're not here to talk really about all the features of Zotonic. We're here to talk about performance. So let's continue with that. So this is the typical HTTP stack that a request goes through. And it probably looks like most of the stacks that web frameworks have out there, except maybe that that there's these templates in between the controllers and the models. And usually in an MVC system, you have your model, your view, and your controller. The controller is in charge of getting data from the database and putting it for use in the template. With Zotonic, we actually turned that around a bit. Because as one of the goals is to make it front-ender friendly, we want the front-ender to be in control of which data get displayed. So for a lot of use cases, you don't need to write your custom controller. So like unlike with, we often say compare to Django, but in Django I think you always have to write your own controller. But in our case, we just have the controller called controller template, which basically renders this template on this location. And then in the template you say, okay, hey model, give me this bit of data because I need it. So templates directly interact with the model, which is kind of an interesting construct, but makes it really powerful and really easy for front-end developers to show stuff. So on a standard Zotonic, if you just want a standard Zotonic website, you don't have to do any Erlang coding, basically. You just make websites, you glue websites, you just make templates, and you glue the templates together on your dispatch rules. Well, besides the templates, there's also, well, there's some REST stuff, as I was saying, and there's an interesting one, there's a WebSocket layer. So it's possible to have an open WebSocket connection with the browser to be able to interchange data in real time in the same process, in the same page, basically. Yeah, and then so the models communicate with the database, but there's of course also a few middleware processes that do most of the work. Caching, rendering, resizing, all of these are Erlang modules and processes. In one of the few earlier presentations, I had a process, a supervision tree in here, but it's a bit too big to fit on the slide. So, but for the steps of a request, this is basically what happens, right? You accept your socket, you parse it, you dispatch it to the matching controller based on the host name and the path. And then you render the template, probably, and the template fetches some data, and you serve the result back. So. Where is the time spent in a typical Zotonic request? Well, for a very simple request that I was just benchmarking, you get around, on my laptop, you get around 7,500 requests per second, and doesn't say anything, I know. Because this is just, I think, a simple JSON request. But for template renderings, the whole loop, like I showed there, without getting any data, it takes like 10 milliseconds or so on my laptop. But it's a fact that as soon as you have content and you want to show something from a place, you're not serving up static stuff, so you're serving dynamic stuff that comes from your database. So if you have more content, you need to do queries or something. So the more content, the less performance. That's a rule, right? So where the optimizations started for us were in fetching the data from the database and rendering the templates, putting it available for the templates. Yeah, so for a typical database access time, a round trip takes about 1 to 10 milliseconds. Of course, depends on all kinds of factors. That's a bit long. Like I was saying, like a page rendering is also 10 milliseconds. So this you're half the time waiting for your database to respond or transfer your stuff. You don't want that. So if you put a memcache or something in between, well, it gets a bit better. But you still have the network factor. So you have the network round trip that also takes some time. So the conclusion is, of course, don't be the cause of any I/O. Basically, don't hit the network. Don't hit the database, and of course, don't hit the disk. Do not do things that you could have done a long time ago. So what we do in Zotonic is we, when content enters the database, because like everybody says string processing in Erlang is expensive. Well, actually it's expensive in any language, right? But it's maybe more expensive in Erlang because you cannot really modify directly a part of your memory. You have to copy it. So it becomes maybe more expensive. And I mean, a lot of the problems are solved with IO lists. But still, like if you want to do escaping in real time or like in render time, why would you do that? Because the content is already sitting in your database. So, and it's just meant to be there to be displayed. So why don't we just escape it while we save it? And it also holds for content filtering. I mean, users might be entering some stuff or HTML codes that we don't allow in our website because they might lead to well, request forgeries or what have you not, custom scripts. So we do filtering and sanitization and escaping before we actually store it. So then on the render time, you don't have to do that again. Then there's another thing. What is also interesting is that we don't want to do the, like I was saying, to do the computer the same things all over the time. So we're combining similar actions into one. So, and that's where the real power of Erlang comes in, right? I mean, how would you do this in a language like PHP? You have no clue what other visitors are there on your website, but in a language like Erlang, every request, basically every visitor has its own process. Like every page request has its process, but there's also one step higher, the user session that also has its own process. So you know that there are users on your site. In your request, you know how many users there are. You can maybe wait for something that another user or browser is doing that looks similar. So yeah, we combine rendering of templates, database results, and calculations into one. I'll come back to that in a minute. But first, a bit more about where we can save the actual time. Because well, websites consist of all kinds of static files, but they also have some dynamic files. And of course, for the static files, well, we want them to be retrieved once, but we don't ever want the same browser to get the same file again. So we do client-side caching. But then again, what we also don't want is that people have old JavaScript files around on their computer that maybe have been updated with a bug fix. So to minimize the number of HTTP requests, we actually combine multiple requests from multiple files into one. So this is an example for some CSS files. One is called Bootstrap, which is the framework that we use. Some base site CSS and some load mesh. So the URL is a bit garbled, but it basically just gets those CSS files, concatenates them, caches them, and then serves them. And then there's this number at the end, and that number is just the maximum, the max of the modification time of those files. So that whenever one of those files changes, the URL will change. So all browsers will get a new file. And we do that, so basically on these files, I don't know how much you know about the HTTP protocol, but we do this by just setting the expires date for the file way in the future. So we say, hey, you can get this file, but it just never expires. Because because the URL changes. Yeah, so yeah, file requests. Well, we also serve some static files like that one, but also just normal static files, just the images, etc. So for those files that cannot do those special checks, like you cannot combine 3 JPEGs into 1 JPEG, right? So you just have that JPEG. So there we need to do a modification date check. But we cache those files in memory. So both the compressed and the uncompressed version, because we don't want to do the compression again when a user asks for a gzipped version of some file. So we just cache that in memory. Our assumptions are that we have a lot of memory, or enough memory. But at the same time, while we're doing this, there's still access control checks in place here, because there might be PDF files that you don't want anybody to see. So it still checks the session for access in this case. But the actual content is not read from disk every time, obviously. What we actually measured while doing some benchmarks on static files was that when we actually tried to put varnish in front of it, which is a caching proxy, it didn't speed it up. It actually only slowed it down because it just there wasn't anything to win basically. Well, it didn't slow it down, but it just didn't get fast. And usually, what they say, hey, you should put varnish in front of it, and everything will be all right. But essentially, what we're doing with these kind of tricks implementation is that we just be our own caching proxy. We have enough memory for that. Yeah, so then we come down to the templates. So templates, they, in most cases, they drive the page rendering, are compiled into modules, and we're using Evan's early DTL, and we're working with it, and we're merging it back. Andreas is doing that right now, 5 minutes ago. And early DTL is basically a language. It comes from the Django template language. That's what the DTL stands for. I just found out actually that this syntax is not standard Django syntax because DTL does not allow the square brackets, which I think it's a pretty big thing that misses. But this it's just a template, and you can just say, hey, the title, give me the title of thing number 1, 2, 3, the page with that ID. And what this actually does, it calls out to model of a resource. The RSC stands for resource. Resource is the base data model of Zotonic, so it contains basically all the different pages that you have. So here it actually goes into the database if there weren't any caching, and it would get the title for that thing. And then in the second call, it goes out of the database and then gets the first image that is attached to that thing. And then the second thing, it actually does a query. So it loops over a number of IDs that it got from the model named search. So it loops over the IDs that are of the type person. So these call out the models, and so we the back-end developers that develop those models are responsible so that our front-enders cannot mess up or make things super expensive. So the stuff gets cached inside those models. But there's also some caching that you can do. Like for instance, queries like that are not cached by default, because a query basically just maps to a SQL statement. But you can put a cache block around it. So you can say, I only want this block to be updated every 10 seconds or every hour. And then the whole content of that block in your template code only gets updated when the cache expires, gets evaluated again. And you can also do that for include. So you can say, I only want this 100 second to be cached. Of course, based on some kind of caching keys. And you can also do this in your directly where you define your dispatch rule. So you can have this dispatch rule that's on the bottom here that says on the URL that's called hello/hello. I have the template controller, and I'm rendering the hello template with once every hour, basically, and serving that from memory. So you might have heard me saying serving from memory a lot of times, and that's actually what most of it is about. We do 2 levels of in-memory caching in Zotonic. On the request, well, basically, every page that comes in, or every request that comes in the web server is a process, right? It's a process, and its life cycle is just from the beginning to the request to the end of the request, where it sends the I/O list back over the socket. So we do in that process dictionary of that process, we do some caching so that we don't have to do anything basically to get the same value twice when we're still in that process. And it might sound a bit dirty, but I think for the purpose of caching, it's okay to use the process dictionary because it prevents any kind of bottlenecks. And then on the second level of the cache, there's one cache process for the whole site, and that's called the Depcache. And Depcache is a bit a play on memcache, but it's basically a memcache with a dependency chain between keys. So you can have keys which are dependent on other keys. And that's interesting because that way you basically can create a graph of keys, and when you flush one of the keys, all of them are flushed. It's actually a directed graph, so if you flush a key that's bent on the water, it doesn't go both. It's not like Erlang linked processes. Yeah, there's this central cache for the whole site. It works. It uses an ETS table. And then when it gets a value from that cache, that's actually then it gets returned to the calling process, and then it can be cached again inside the request process if it needs to be. Yeah, and then there's some oh, okay. Yeah, so the in-process heap is used. There's some often used values for the memo cache, and actually there's also some sanity checks running there so that the process dictionary doesn't overflow to be too big. So that you can somebody might exploiting the process dictionary, some caching mechanism to force a request or something so that it can explode, but it doesn't happen. Yeah, the Depcache, as I was saying, is ads-based central cache per site, and it also has a garbage collection mechanism which basically does random eviction. So every now and then it just goes out and flushes a few keys, because to make sure it doesn't grow too big. Again, if it can grow too big, of course, then at some point things can go wrong. And then sharing. Yeah, that was what I was saying about sharing the computations between processes. Like if you cache a process, or if you cache the result of some function, you cache it for a few seconds, then other people can also use that, right, in that time period. But if there are simultaneous requests, they actually, how do you say that? Well, the setter function basically of the Depcache mechanism. The Depcache is a gen server, so when you Depcache set, it actually calls that server. So that's a single funnel. So that server knows when there are multiple people actually wanting to set that single key. Yeah. Sorry, it's pretty hard to explain now. That single server then knows which other processes are basically asking for the same key. So it can just pick one of them and let him do the actual calculation, and then when it's done, distribute that value to all the other processes. Because it's Erlang, it's functional, right? So if you have a key and you have a function, then you always know the answer. So it's the same for everybody who wants that computation. So it even helps if you do a memo of your calculation with a timeout or a time to live of 0. That even helps for when you have a lot of requests doing the same thing at the same time. Yeah, with regard to the Erlang virtual machine, well, you already know this. Processes are cheap. Data copying shouldn't really do that between processes. Binaries are okay. String processing is not okay. And in Zotonic, it's especially important because we have one big. It's a data structure that contains the base of your site. So it's a record that has it has a few things in it. It knows, okay, I'm now doing this site. I know where my database pool is. I know where the PID of my Depcache is, etc. And then it also contains the whole. If it's a web request, it contains the whole web request. So it contains not the body, but it contains the headers. Not contains the headers and then the method and stuff like that. So we don't want that thing to get copied everywhere because it can be a large thing. So when we do messaging, so we actually, because it's an extensible system, there's a lot of messaging going around. There are multiple hooks inside Zotonic for doing stuff and extending certain aspects of it. And so when we do those notifications and basically broadcasting through all the interested listeners, we don't want everything to come along. So we have for different use cases, we prune that context variable in a different way. Yeah, messaging binaries is of course perfectly fine. Yeah, in our stack, I didn't talk about this yet, but our stack is actually a mochiweb, which uses Webmachine as controller. So our controllers are actually just Webmachine resources. We renamed them to controllers because our resource are actually like the things in our database, so that's very confusing. So we have controllers that are used by Webmachine. Webmachine is basically HTTP flow mechanism which guides a HTTP request through all the different states that it can get into. Like, should I return? Is this resource there? Can I access it? You have all these kinds of callbacks that you can hook into. It's pretty nice. If you don't know about it, you should check it out. So mochiweb calls Webmachine, and Webmachine basically uses our controller callbacks to do the things. So what we don't want to do is any. We created a fork of Webmachine because there were some things that were not really optimal in there. For instance, when you fork off a new Webmachine callback, it just copied the dispatch list to that request and let that request do the dispatching. But dispatch lists can be really big, and especially if you have multiple sites, they become basically huge. So we didn't do that. We do our dispatching currently in a central mechanism, in a central gen server. Well, we stopped using the parameterized modules and did some more optimizations, like don't use the process dictionary for the main process, and I wrote actually the custom dispatcher because the original Webmachine did not support virtual hosts at all. I don't know how that is now, actually. I think it does. Yeah, and so when you initially start up, or when there's, in the situation when there's nothing yet in the cache, when you have a clean slate, or you type flush in your Zotonic console, we should prevent the system from doing many things at the same time. Like I was talking about templates, for instance, or about image resizing. If you flush your resized images directory, you don't want everybody to spawn off an image magic convert command. So there are some artificial bottlenecks in the system. So there's a single template compiler process which just compiles templates for you. They're actually not stored on disk. These templates are just modules in memory. There's a single image resize process, and that's maybe we should do that in a pool. I don't know. It depends on the use case. And there's the memo cache that I already talked about, the sharing computations. And for a recent project, I even made a Twitter fail wheel module that actually just measures the system load on per request, and if your load becomes too high, it just serves a 503 page. So it will just say, hey, we're down. So that's also a way to protect your resources from becoming too overused, right? And then there's a retry after header, which says, okay, come back after so many seconds. That module is actually not part of the standard distribution. It's in the modules repository, right? No? Oh, it should be. Anyway, what about real raw performance? I don't know if you know this. There's this techempower.com website. I think it's a Java shop, and they really like doing a web framework performance tests. So people have been asking us, can you submit a performance test for Zotonic? And yeah, of course we can, but we don't have enough time, and we don't really see it as a problem actually currently. I don't know why. I think it's just a matter of scale, or maybe we're a small country. But I mean, we never saw like raw performance as a big problem for for our web framework. But you know, there's all these, like, there's I think like some 63 frameworks currently that have submitted their tests. So, well, I thought, well, we know that we're not the fastest, we're also not the slowest, so yeah, let's just do it. But then you can ask this question: so how important are these performance tests really? Like the first test that they have is just encoding a JSON, on a URL, encode a JSON message and send it back. So in that case, what are you really testing? Like, I mean, are you testing your JSON encoding library? Are you testing your HTTP parsing? Even your kernel basically? I don't know. And we know that we're not the fastest out there. So here are the raw numbers. So when was it? Yeah, last week I did some tests on my machine. I tested, there's actually Cowboy out there in Ellie. It's other Erlang, it's a newer web framework. And then there's Zotonic, which is, it's not even in the same ballpark. But I mean, Cowboy and Ellie, I think the biggest win there is that they both use binaries and not lists for their web serving. And we use mochiweb. And then Node.js, it's a bit in the same ballpark. So I did some tests. Okay, let's see how I can speed it up. Because by default, Zotonic does access logging. And I mean, Node.js doesn't do it, etc. So we turned that off. It got better. I fiddled a bit around with the dispatcher. It got better. So we know where to look. And it's we're actually thinking of switching to either Cowboy or Ellie. I don't know who can convince us first. Yeah, so it's actually it's an ongoing process to make it better. But then again, this was the most basic test, right? And it's like 8,500 requests per second on a laptop. I mean, what do you really need? But of course, we can improve stuff. What we're thinking of is doing the whole dispatching mechanism, actually doing that in compiled. So we compile a custom Erlang module for the dispatching, so we can really use just binary matching in like a one function clause per path, basically, that's automatically generated. And well, migrating to another web server, that's one of the big wins. And then there's some more things like Webmachine can be optimized more by preventing more copying, etc. And then yeah, the templates that are rendered also, they check whether they have been changed. So that's also that you can either choose to switch off, but then you lose your whole. I change this and I do refresh, and it also changes, right? That's also a bit. So it's always a trade-off. Like how nice do you want your system to be, and how fast do you want your system to be? I think. And yeah, then they pose some artificial restrictions, like they have one template rendering test where you're not allowed to do any memory caching, and that's one of the things that, I mean, that's pretty obvious to do. Even if you don't do it, I mean, this way you're just testing your database or something. I don't know. Yeah. So these guys, these are actually our king and queen now. So one day, there was this, we got approached like over a year ago to do a super secret project. We didn't know what it was. We only know that it has something to do with the orange color, because all the logos were blurred out and there were no images. And we had to make some kind of voting website. And they came to us because, they knew they wanted something. Basically, it was a web shop that used, I think, some .NET product. And they had, their client was the Oranje Fonds, and they approached us. Okay, we don't trust our .NET product to be very fast, so we want you guys to do this project for us. So it was basically about a nationwide voting week. I don't know if you heard about it, Kroonappels, you're Dutch, right? Yeah, it's basically, oh, sorry, I need to do this. Yeah, so it was this voting weekend, and where people could could contribute their projects. It was like nationwide, like social initiatives, and people could say, yeah, I have a nice initiative here, and then people could vote on it per neighborhood, basically. And then in that weekend, people would, the whole of the nation would vote on those projects, and then the winner would get 50,000 euros. So it was a pretty big reward, so they expected a lot of it. So they requested really, well, high enough performance and availability. It shouldn't go down under any circumstance. And they said, okay, we need you to do at least 100K votes in 1 hour, and when you voted, you would, I think, do something like 30 requests. You have to do some pages, there were some checks, there were some captchas, etc. Yeah, so we run this on 3 VPS machines, not really big VPS nodes, but for, enough, as we found out, of 2 gigabytes load balance. And so request consisted of everything, a mixture of dynamic stuff, some no WebSockets, but just some AJAX, and some static assets that also were just served off Zotonic, because why not? So when they tested it first, they couldn't really get it to go any faster, because they were testing it from their office, and it only had I think, I don't know, 200 megabit fiber connection or something, and they just had to move the test somewhere else, because they couldn't push it to the max. So we stopped testing at about 500,000 votes. So that's it was a pretty nice project to do, and the customer was more than satisfied, because we exceeded their expectations, basically. And it run off pretty much commodity hardware, right? It's just 3 virtual servers with 2 gigabytes of RAM. So it wasn't state of the art. And we made it so it ran off 3, actually 4. No, it ran off 3 web servers, and one was like the management database, the management server where they could log in. So we made some nice graphs to see what was going on. So every request basically had to do some kind of query, because it was dynamic and people couldn't vote more than one. So it was not all like just spitting out static pages. There was some actual business logic there. And this was basically, you see here over the course of the weekend, you see like how the customer, how the request increased and decreased. So when we thought of this, we thought, well, Zotonic has been around for, I think, 3 or so years, and we were also thinking, what's the next big step for Zotonic? Because we know we just use it on our daily basis, and it works pretty well. It has a bit of quirks, but it's okay, and I mean, you can make websites with it. What else is there? And people are always saying, like, okay, you should scale out. You should make your system elastic or dynamic, or do something with Dynamo. So because then you can scale maybe even more. So what we did with Mark Worrell actually wrote most of the code, but I helped him out. So we made Zynamo, and it's basically the Zotonic version of Dynamo. Dynamo is the paper about consistency versus availability versus partitioning. So the Dynamo, we had our Erlang nodes set up in a distribution ring, so we could store stuff there, and we could query the other nodes. And then, I'll hurry up a bit. So yeah, we basically, I don't know if you guys know React Core. That's like the layer that the React is built on. It's like a work distribution also over a consisting hashing ring. So we used that, but we made it a bit simpler, because React Core is, well, for just work distribution, it's a bit over the top. But it had a nice, it has like a service architecture where you can, every Zotonic node could basically announce their services, and then people could query for services. But it was hard to maintain, and it didn't really fill any. I mean, we could easily handle the load, but probably if we would have had a slightly more bigger machine, we could have done the load with a single machine. So So after that, we didn't really do anything with Zynamo. We're still planning on open sourcing it or making it like into a separate application, just for archival purposes, if that's all. And there are actually many DBMSs that couldn't do the same stuff, like it was in the VaultDB presentation. And I mean, they are almost in the same area. So do we really need this skill? Like for most of the websites, is it really an issue to, we're not Spill Games. I'm never going to make a site of that skill, and probably most web developers won't. So do we really need it? And so Zotonic has a sweet spot somewhere between WordPress and Spill Games, basically. So what do we want? We do want our sites never to crash, right? We don't want to have, we want uptime. So we do want to have multiple machines, but we do want error recovery. So our next thing is, or like our current research, is to do some kind of distribution and fill over where you have multiple nodes, but not in the same data center, because the whole data center can go down, but on different nodes, and they communicate via some kind of peer-to-peer kind of ID to rely on you have few Zotonic machines that know of each other's existence and can, they can, if one goes down, the other one can take over. And then maybe even running our own DNS server so that clients won't know that something has happened. Yeah, so that's basically it. So most of this talk was based on the book chapter that Mark and I wrote that's coming out pretty any moment now. About the performance of Zotonic application, performance of open source applications. Yeah, so feel free to chat with me afterwards, and if you want to get a Zotonic t-shirt, you can also contact me. And of course, check it out and go to the website or follow us on Twitter. Thank you very much.